Hello, I am Andy. Welcome to my channel. I've had my channel for quite a while now, but I have never got serious into it. I am hoping to change that. And I am sorry in advance that these videos are going to suck for probably quite a while until I get used to the camera settings, video editing, lighting, sound, everything that has to go along with it. This is all new to me, and please bear with me as I figure things out. About me, my channel, my shop, basically a job shop. There's gonna be a little bit of everything. I'm not set on one particular thing here. I do it all, whatever comes through the door. I do fabrication, welding, machining, vehicle, mechanical repair, anything and everything. I have never showed my face in one of my videos before, and I have never spoken in one of my videos before, so this as well is new to me. Again, I am sorry in advance. My shop is cluttered, dirty, and maybe a bit dingy yet. Mainly because I have a lot going on. I don't have much time for cleaning. I try to keep as clean as possible, but that doesn't happen a lot. I hope all three of you enjoy my videos. It will be painful for a while. Maybe for a long while. Maybe forever. Like I mentioned, I do a lot of fabrication in my shop, and I just so happen to have the exhaust almost finished on this very nice Trailblazer SS Turbo. You can see this is 4-inch stainless all the way back over the axle. V-band flanges throughout. Stainless muffler. Flex section. Down pipe, and it goes up and hooks up to the turbo. Today I am going to be working on cutting out a stainless flange for the dump. This guy has an electric dump somewhere. It's back by the plasma table. That goes here, but we can't have it just dump straight out onto the transmission cross member. So we need to build a flange, cut out a flange to sandwich the dump valve, and then we are going to be doing a turn down to get that exhaust to go down. That is what we are working on today. Like I said, the exhaust is nearly complete. The sides is turned down, and I have to wrap the downpipe with this fiberglass header wrap up there to keep the heat off of things like starters, plug wires, hoses, plastic splash shields, heater boxes, and whatnot. Well, let's go back and see the plasma table. It is much darker in this part of the shop and colder. I am in Wisconsin and it is about 23 degrees right now. Sorry for the lighting. I haven't upgraded the lighting in this part of the shop yet. Hopefully you can bear with me. This is my CNC plasma table. It is a Plasmacam. Yep, has worked well for me over the years. And here is the electronic dump. It's just an electric servo motor that opens a flat valve gate, what you want to call it. This bolts on to that dump, like I said, and we got to build or cut out a new flange to sandwich this so I can weld on that dump on here so it doesn't blow onto the transmission cross member. And we'll get started on drawing that up now. This is a generic template that I use for doing flanges. This is a 3-hole flange. Basically it gives me all the dimensions I need to start with basically any 3-hole flange, much like that, the flange that we need. From here I would measure out the distance between 2 of the bolt holes, and I would make that match to these, so that distance would be correct. Next would be the size of the holes, make these match to the same size, and there, from there, it's easy enough to just do the center circle diameter and the outside. Well, let's get started on that. Measure across the centers of the holes, and looks like we are at 4 5/16. And I don't know that off the top of my head, so we go to my little cheat card here. This has been very handy for me. Right here, 5/16, zoom, focus. Why is this not focusing? 5/16 is 0.3125. So all I do is do a line at 4.1, what was it? No, 5. 4.3125. 3125. There is our line. Why does that seem so big? Oh, it's because so this line from point to point is a distance between the center of the 2 holes on the mounting flange. So I would just take these, or this, and scale it up. This is hard to do with one hand. Here, we'll put this somewhat centered in the hole. over, then we'll rotate this off that axis till this hole right here is on the line, like that. And then we just scale it from this point of the line until it is centered. The end of the line is centered in this hole, and that is our 4.3125 bolt hole center. Now yes, these bolt holes are much bigger. We'll go back and we'll scale those down 2 size next. Okay, these bolt holes are now 1/2 inch. That's what the holes are in this flange. The way I did it is the circles or holes that were there before, I just highlighted them all and scaled them down to the 1/2 inch size that we needed. Next thing you can see, I have my center right here. That's my center. And then these bigger circles I was just using for reference for an outside diameter on flanges. That gives me a little space here for the outside edge from the bolt hole to the edge. From there you can do arcs across, straight lines across, whatever's needed. You see this one has an arc. It's basically like a circle. So we'll be doing that same thing to try and match that profile. First, because it's easy, we'll just click on the center here after we measure this again. Very sorry for the jiggly camera and stuff. Like I said, I am not set up perfectly yet. I believe this is, we're going for 4 inch, the same as the exhaust. Yeah, it shows 3 3/4, but you can see there's this little jog here that is for that plate to stop on. You see that plate stops on a flat then on each side. The plate overall in the big area, sorry again for the jiggly camera, is really close. The exhaust is 4 inch, so we're going to go 4 inch with this hole, just because I want to make sure it's going to clear this plate in here. I don't want it hanging up on the edge on the exhaust. So I'll zoom in. Oh, you can see that line isn't perfect. Line right there. That's my center of my whole entire flange. I'll push Q for a circle, click on it, and just type in 4 inches, enter. We zoom back out. There's our 4 inch hole for our exhaust. From here, like I said, I just have to do an arc. I think I'm just going to do a bigger circle that matches the outside of this for the outside diameter of the flange. So I think that will match this profile pretty well. If it's a little off, that's not a big deal for this. I don't know if that's standing proud or not in there. No, the flange is bigger than this collar, or thicker than this collar, so that'll be okay. So I'll just measure across here wherever my little tiny tape ruler went. And that is about 5 inches. Wait, that's a hard measurement again. Yeah, about 5 inches it looks like would be the outside. So again, we'll zoom in to the center. Do Q for circle again. Click in the center. and do 5 inches. See what that gives us. That goes right through the bolt holes. Perfect. No, we'll go with that. That'll be a 1/2 inch on each side. That's about what we have here. I will just do an arc in between here to smooth out these lines. And how we do that, zoom in here, we'll click U for arc. And I'll just come off of somewhere off this side. Go to this bigger one and then see, you can do an arc either way. That doesn't look like it's going to land very nicely right there for this one, so I'm going to move that over a little bit. Try again. Go a little bit right off this point. Just like that. That'll look good. And then we just break these other ones. And we'll do that all the way around, and I'll come back when it's done. Alright, you see I copied that same profile I did over here all the way around. So now we got our flange. I deleted the lines in the middle that we didn't need anymore, which I can do with the rest of these now. Let's see, we'll just, how do we do this? Clean. Sorry, again, this is one-handed. Clean. Clean, clean, and there's our flange. You see this is all separate pieces. And Plasmacam, we just link pass, and there we go. If this was real size, well, you see that profile isn't perfect, but it changes a little bit all the way around. You can kind of get an idea. It's going to dip in a little bit. I made those outside ears a little bit big. That's what they were from the beginning. You see those outside ears were a little bit big. The rest of the profile is pretty close. Okay, we are ready to cut our flange. I already did a bunch of test cuts inside of what's going to be the waste material, just because I had a problem with the tip on the torch. And I changed them out for new consumables, and we are ready to go. Sorry if the fans are loud. I hope you can hear me. I've done some mods to my plasma frame. You see, this probably stands out. This is actually a post with a spring on it to help the gantry up and down. I use a wood router on here sometimes for carving plastic, wood, what have you. And I put this on here just to help, because these older models, the DHCs, have a weaker, what we call it, Z-axis motor. The DHC2s have a much bigger stepper or Z-axis motor on it. They can handle a lot more. I'm just trying to help it out. I made this mount down here. I don't know if you know what the original Plasmacam clamping system is down here, but it's just like these. It's kind of like a couple of alligator mouth clips that would clamp onto the torch. I made this mount. It's a thicker plate with a hole just a little bit bigger than the snout of my plasma or my hypertherm torch. That fits right down inside of here nicely, and I go all the way down until the torch bottom. Sorry, my battery quit. What I was saying is, I made this mount so the body or base of the torch bottoms out on this mount. So I can pull the torch out, change consumables, put the torch back in, and I don't have to redo my height control settings. which I used to have to do when they had these little alligator clamps in there, because there was just no setting the torch at the same exact height every time. So now I change my consumables, put it back in the stone, push it all the way down, tighten the clamp, and we're ready to go. The torch is right at the same height that it was before, and as far as it knows, I didn't do anything. For hvac, all I do is run a couple of box fans. These are very cheap fans. I only surprisingly had to replace one in all the years I've been cutting, and obviously you can see I cut quite often. I just emptied out my table down here, I think 3 weeks ago. So yes, I do quite a bit. This table, the screen top catches parts, and then a flat plate bottom, this flat plate pulls out so you can clean it. It works alright. I would maybe do it differently if I did it again, but it works okay. You can see I covered in both sides of my table to help with the draft flow. That is just like metal pull shedding, pull shed steel or roofing material. And then on the front side here, so I'm able to get to my parts, I just have a couple of sheets which I pull over. There's a little bit of gap at the top here, but that doesn't hurt the airflow. Simple, but it works. Like I said, I have my stainless sheet loaded here. I already did some test cuts. Like I said, I had problems with the consumables and the torch, so I changed them, and this is my last hole, and it came out pretty nice. This is 1/4 inch stainless. I wanted to get 3/8, but this is what they had in stock at the local steel supply. Nice that they have their shipping label stuck right to it. That will be awesome when I get to that section later. So the next step, the inside holes is where I would start, and I guess I can start with these. So I'll just do cut, and it'll go through. Cut every one of these holes. This one, normally I would highlight all of these and go after it, but I'm one-handed, so we're doing one at a time. Cut, next hole, and final small bolt hole. And then we will go with the 4-inch hole. Just want to make sure that's not going to get in the way. That's below the surface. That should be okay. And finally, the outside diameter. Just like that, there's our flange. I hope you can hear me. I know everything is very loud, especially when the plasma is going in. A little bit of a tag on the end there. There we go. There's our flange. Let's see if it mounts up to this correctly. This is hot yet, I don't want to touch it. Don't want to drop the gate on the ground. Alright, so there we go. You can see, hopefully you can see, all 3 bolt holes are in the right location. Try to get that centered up. The outside diameter is right for the most part. There's a little bit here, but that'll be okay. The main part, besides the bolt holes, keep moving this around, is this inside is going to clear the gate, the plate, whatever you want to call it. Okay, moving back to the vehicle and mount this stuff up and go on to the next step. Oh, after I clean this up, I'm going to wire wheel it, take it to the belt sander and clean up all the edges and make sure it's good. Plasma does a fairly nice job. You can see that edge, fairly straight, fairly clean. Not much, if any, dross at all on the back side. I'm very happy with the plasma table. Saves me a lot of time and gives me a nice product. Right, on to the next. Back into the warm part of the shop. Oh goodness. Alright, this is my belt sander. I built this. A lot of it cut out on the plasma cutter you just saw. These are all 1/2 inch plate. All of this was all cut out of 1/2 inch plate and welded together, bolted together in various things. The wheels I all turned out of solid aluminum on the lathe. Just standard, what are they, 6336 bearings? Is that what they are? 6036, 3536? These. I got a bunch of them lined up on here for a smaller wheel for doing radiuses and whatnot. I have an extra wheel down here that I had planned, or this stub. I actually planned on putting a bigger wheel on, or this one of the two, for bigger radiuses. I just never got around to it. I have 3 slots, obviously one for the attachment itself of whatever I'm using. Second slot or third slot, I eventually am going to get around to building a table, so I can lay parts flat on the table, put them up against whatever I'm grinding. The motor is a, what is this motor? I believe it is it's a DC motor. 1.5 horsepower, 1750 RPM. The controller, I forgot where I got this controller. I don't know if it came with the motor or if I got this separately. Just a toggle switch and speed control. I do have to do a better job with a base on the top. This is just temporary. The bottom part, this is actually an old tower or stand for a alignment machine. The electronics, the alignment machine went bad, so I salvaged the case, and I wasn't planning on using it for the belt sander, but it has worked out very well for it. Like I said, I'm still not done, even though it's been like this for a couple of years. I'm still not done with finishing off this base. I want to do a better top for the sander to sit on, and I would like to do a catch off of this side for catching material coming off of the belt. But it works well how it is. It is on wheels, and yes, when you're pushing on this, it does want to move around, but luckily these wheels have brakes on them. When you put the brake on, you can push fairly hard on here before it moves. I like everything in my shop to be on wheels, just because my shop is small and cluttered. I like to be able to move things out of the way when I'm not using them. So let me start cleaning up this flange. Hopefully that's good. Glasses. It's a little coarse. We'll switch off for this one. That was an 80 grit, and this is 120. Cleaned up nice. I didn't go completely down on the surfaces. I don't think it really needs it. It's fairly clean how it is. Let's get everything bolted up on the truck and start looking at our downpipe, or turn down. Okay, I cleaned up the edge, squeeze it down in the vise to get it round, because these bends are never perfectly round. When you run the mandrel through it, it gets a little oval shaped. Not much, but enough where when you have a perfect round flange like this, it doesn't want to fit in there. So I squeezed it down, I wire wheeled the edge to get it nice and smooth, and let's see, get better grip on it. Yeah, there we go. It even holds itself. There we go. Let's get this light out of the way. Find a better spot for that. this so it's facing down. Actually, there's enough movement off to the side. I wonder if that would be better or not. Like towards the side some. What does it look like? Well, I think we just go straight down. Problem with blowing it off to the side like this from here is, especially on a turbo vehicle, there is often oil blowback out of the exhaust, and if you turn it to the side, facing it out the side of the vehicle from inside of the wheelbase, you can blow oil on the ground and it'll go all the way back and hit your back tire and cause problems. So we're not going to just leave that dangling down like that, obviously. You gotta take a marker, following along bottom of the vehicle, and mark this pipe. Following along as best as possible. This is the bottom of the vehicle, so it's nice and flat. That's not the greatest, straightest mark, but it gets us in the ballpark. Finish it off up here. Oh my gosh, that's horrendous. Now, if you look down the bottom of the vehicle, it'll stick you up here, you can see that line where it is. Nothing will hang below the vehicle, but it does enough where it doesn't blow the exhaust all over the bottom of the vehicle. It blows it down towards the ground. And now we go cut it. This is always sketchy to do by hand, so enjoy. Yes, it would be nice to have a big plate here to lay this down on, like a typical vertical bandsaw. This is a horizontal in the upright position. All I did is this little plate. This blade is old. It's missing some teeth. It's bent in a couple of spots that I saw when I was going around. I usually go through because I cut dry as well, I usually go through a blade per exhaust job. I always factor this in for the cost on an exhaust job, especially cutting thin stainless like this. These blades catch every now and then. They get wasted, and even the, I mean, yeah, this blade is shot. But I love the bandsaw. This is the workhorse of the garage. I use this a lot. You can see it's been around for a while. It is time to upgrade and get a new one. I would love one of the Ellis saws with a pivoting head, because setting this up for angles is a royal pain, but it works for now. Yeah. Let's see if this fits like it should. Here, we'll get it nice and level. Like that. That looks pretty good. Nice and flush-ish. I think that'll do well. Let's clean it up, get it tacked to the flange, pull it out, go to the bench and weld it up, and then the fabrication and welding part of this exhaust job will be done. Like I said, I just have to wrap the downpipe yet with the fiberglass heat wrap, and this guy should be here, what, today is Friday, this weekend, tomorrow or the day after, to pick this up. And then I have another vehicle coming in for intercooler work. It'll be aluminum. That's always a good time. Oh, let me get this cleaned up and get the welder over here and we'll do some tacking. I don't know how these cameras do with welding. I'm assuming not very well. This is going to be another battle for me because I do a lot of welding, obviously. And trying to figure out how to get you guys to see the weld and what is going on. It's going to take some time. Sorry in advance again. I got my pipe cleaned up and up in here. All I'm trying to do is just tack it in place. And once I have a couple of tacks on it, I'm going to take it out, go over to the bench and weld it up. Hopefully I can get it up in here. Couple of tacks, one on each side should be enough. Well, maybe I'll go through. It wants to move. So, gotta hold it in as I'm tacking. Good. I'll do one more. That squeaking is my chair, by the way. I like working out of a chair. I actually have a leather office chair. I get them on auction for like $20, and they work perfect for working underneath a vehicle on a lift like this. You can sit back, you're comfortable. You can wheel around. You can adjust the height on them. You can lean back on them. They're perfect for this. You always want to be comfortable when working underneath a vehicle. Otherwise, if if you're standing, it's hard on your back. You're leaning back all the time. Do much better work if you're comfortable. There we got 3 tacks. And that'll be enough to hold it in place. Take it over to the bench to weld it up. Again, welding on the bench, you're more comfortable in a better position, you get a better weld. It's all about being comfortable. Not only for yourself, but the quality of work as well. You get much better product if you're comfortable in using. Yes, that's the correct tool for the job. Just put this one nut back on so the gate doesn't fall. There it is. It sits nice and flush. Let's go weld it up. These are my Jackson helmets. This one is my original. Can't see because I don't think it focuses good enough. These GoPros aren't very good at focusing, but that's 1989. That's how long I've had this helmet. I've changed the headgear because obviously the headgear gets worn out and cracked up. This lens, this is a 13, a passive 13 lens. The reason I got the new one is because I wanted a little bit lighter shade. For welding thin aluminum and smaller parts, I was having a little bit hard time seeing with the 13. So this is actually a 11, I believe. I don't remember now. But I just got this helmet like 2 weeks ago, and you can see Jackson's design has not changed in all of these years. 1989 lid to 2022 is exactly the same. It's a good helmet, I like it. It's cheap, bare bones, gets the job done. The only difference I have noticed, I don't know if you guys can tell in here or not, is the thickness of the helmet. This old Jackson is much thicker than the new Jackson. Cutting down on material cost, I assume. But I'm happy with them. They do their job. So with the stainless, we'll be using the new one here today. Get this flange up here. There we go. Do some post-flow coverage. There we go. There's the flange all welded up. Alright, let's go throw it back on. But there we go. that is it for the fabrication of this exhaust. Four-inch stainless. All the way back. And out. I would like to thank if at least one of the three of you made it all the way through this video. That is quite the feat. I am sorry for your pain. Go have a beer. If you want to suffer more, come back, watch for more videos. I hopefully will be improving on every one of them. Like I said, this is a big learning curve for me. I have never talked in a video before. I never put this much effort into a video before. So I'm hoping every one from here on out will be much, much better. As I learn what is needed, I do know for sure I do need an external mic. I know that's a big one with these cameras. I'm hoping the sound throughout this whole video wasn't too terrible. The other one is I'll work on lighting and obviously the editing. I'm not expecting this video to be great, but it's a start. Like I said, I'm glad if any of you have watched this video. I go by VPT Fabrication on Facebook and YouTube. I don't do Instagram or any of those other things at all. The YouTube and the Facebook take up enough of my time. I've got a lot going on, and just the shop work itself consumes me. I've always wanted to share the videos. I hope eventually somebody can learn something, and I hope I can learn a lot by others' inputs. If you got anything to say about anything, please leave your criticism or anything down in the description. For this truck here, all that I have left to do is wrap the downpipe, like I said, reinstall the exhaust. I will be putting a gasket in that dump. I'm not doing the wiring. That is going back to owner. He's going to do his own wiring. That is it. Everything else is all V-bands, so there's no gaskets anywhere. I love V-bands. I've always pushed anybody that comes through that is getting an exhaust to use V-bands. It's one bolt or nut on a clamp. It's self-aligning, it's self-sealing. They work great. Yeah, like I said, you should be picking it up tomorrow or the day after, and then the next car coming in is intercooler work. So hopefully you come back and check out that crappy video. Thank you guys very much. Have a good day.